Hello and welcome to another ANSYS video tutorial. In this tutorial we're going to look at the bending and angle of twist in a non-symmetric cross-section. Here's our cross-section. It's shown here and the dimensions are shown. We are going to make a simply supported beam out of this cross-section that is 2.1 millimeters long. So to begin with, we'll open up ANSYS Space Claim, and I go to File, Space Claim Options, and check my units to make sure my units are in metric. So I have metric and millimeters, so I'm okay. I can go ahead and hit cancel that. My sketch plane is the XY plane already. That's selected, so I can click on Plan View. Now I can come to Sketch Mode and click on the Line tool. I'm going to start this at the origin, so I can just click and then drag my mouse and I can type in 70 millimeters because the blue horizontal dimension is already highlighted. So I'll type in 70, enter. Now I just need to move my cursor straight up and I can type in another 70, enter. Then I come back along here and I come back 60, so I can move my mouse and type 60, enter. Now I can move down and type in 30, enter. And now coming back, I know that the beam member is 10 millimeters wide, so I can move in here 10 and then just left click, move up here 20, left click, move over here 40, left click, down here to 50, left click, out to the end, left click, and then back to close it and left click. And there's my geometry cross section. Now I'm ready to go ahead and pull this geometry, so I'll just hit Control middle mouse, move it down to this edge a little bit, hit middle mouse button and rotate. Now I'll come up to the Design tab on the top menu. I'll click Pull. I'll come down to my geometry, select the area, and I'm going to pull this length half of 2.1 meters. So I'm going to go 1.05 meters. So that will be 1050 millimeters, and I'll click enter. Now the reason I'm doing that is because this beam, I'm going to want to put loads in the middle of the beam, and it's nice to have a beam split there or broke there and up to that point. The easiest way to build the other half of the beam is just to hit Control middle mouse and move the beam down to this corner. We can zoom out a little bit to make the beam smaller, and I'm going to come up here to the Move tool, click on Move, then I'm going to come down and select this body over here in the structure tree. I get this coordinate system that shows up, and if I hit Control and the X-axis, or actually the Z-axis arrow, I can click on that and copy and move this beam. And I want to move this beam from the center there, so I will release the Control button and type in 1050 millimeters, enter, and I have now moved the beam, copied and moved the beam to the other end, and I have my full beam width ready to bring in to ANSYS Mechanical now. So after opening ANSYS Mechanical, I can see that my geometry has come in two parts. I can click on geometry in the project tree and see that I have two parts here as well. What I need to do now is look at the connections. So I'll come down and open the connections window, drop down tab, and when I click on contacts, I can hit this drop down and click on the region, and I can see that my two beams are connected together, and I can see the contact and the target faces. I can see that the type of contact is bonded. So these beams are essentially welded together at this point, which is just exactly what I wanted. Now, in order to determine the angle of twist, what I'm going to have to do is put in a joint on the face here at the intersection if this is where I want to know the angle of twist. So I'll put a joint in there, and to do that I come to Connections and right click and Insert Joint. And now you can see that it's brought this joint in here. I am already clicked by default onto the details of that joint. And the first thing that I want to change here is I want this to be a body to ground so that I get the angle relative to ground. Then I want to change this from a fixed type connection to a general joint. Then I need to make sure I change all of these translations and rotations from fixed to free. So I click on it, change it to free, click on it, change it free, same thing here, and then on the rotations I'll change all of them to free all. Now as I continue to scroll down, I need to change the behavior of this joint from rigid to deformable, so I'll click on deformable. Now I come down and I need to change the behavior on the mobile to deformable as well. So I click on that and click deformable. Now I need to make the selection. To get the selection, what I want to do is click on this geometry tab here to close the worksheet and go back to the geometry. And the easiest thing to do is just to come up here to geometry and click on one of the bodies, right click, and then hit hide body. And now I've got that other body hid. I can middle mouse button and rotate this around and zoom in. And now I want to come up to the face select tool along the top menu up here, and I'll click the face select, and I'll come down and click that face where the two members are joined together. I'll come back to my joint and click on that and the details of it. I can see geometry, and I see that I still have that face selected, so now I can click on apply, and it gives me the one face and shows me that I have that face selected, and that is where my joint will be. I now have green checks on all my joints and all my contacts. I can close this. I can come back up here and right click on that and click on show all bodies. Now I've got all my bodies back. I can come over here and hit my ISO view and scroll in, hit my ISO view again, zoom in a little bit or zoom out, and there's my body. I can move it to the center, and that is the main setup. I'm ready to go ahead and start to mesh this beam. To mesh this beam, I'll come and click on mesh, and I'm going to come to click on method, and I'm going to click on automatic method here and come down to the details of that. For selection, I'm going to select both my beams, so I'll click and then control left click and hit apply on, so I have my two bodies, and I'm going to change this to hex dominant and show you what can happen. So hex dominant means that I'm going to use hexagonal elements. They're usually very accurate and work well, and I kind of have a square rectangular type cross section, so this should probably work fine. At least that's what you can initially think. I'll click hex dominant. I'm going to come back to mesh, and I'm going to increase the resolution on sizing. So I'll click sizing, open up that drop down, come to resolution, and I've got it at the maximum of 7, so I should be pretty good, and I'll hit enter there. Now I'm going to come up to generate, and I'll generate this mesh, and when I do that, you can see that I get this error down here that says quality targets are not satisfied. So what I want to do is I come to this mesh quality worksheet, and as I scroll down through that, I can see that my maximum corner angle and my maximum skew are in error, that they're not good enough. And so what I need to do is rethink how I'm doing my mesh. And I can see that my mesh looks kind of ugly here in some spots, and it's trying to merge things together and make nodes and elements that are not quite uniform. So I'm just going to come back to the hex dominant, and I'm going to change this back to click the drop down and just let ANSYS see what it can do and change it to automatic. So now I'll come back up here and click on update. And when I click on update, I see now that there are no messages. I'm ready. I can come and click on my mesh and see what my mesh is, and I can see that that is a very nice looking good mesh that should work for what I'm trying to do. So now I'm able to go put on the loads and the boundary conditions. So coming to static structural, I'll click on that, and now I'll come up to my displacement boundary conditions, and it's a simply supported beam, so I'll click on displacement. Now I can zoom in and click on this front face and rotate around and control click this face, and I have the two ends now, and I'll click apply, and I'll go ahead and fix these in all three directions. So 0 displacement in X, 0 displacement in Y, and 0 displacement in Z. And I'll come back and hit the ISO view again. I now have my boundary conditions set. You can see I got my displacement components set at 0, 0, 0. And now I can go ahead and enter in my force. So to apply the forces in the boundary conditions, I'm going to come to static structural, and I've already done that, but I'll review what I did. The displacement simply displacements 0, 0, 0 on the edges, like or on this face and this face, like we talked about. To set the force, I'm going to click on force and show you what I did. I've got a force along this top line here, so what's easy to do is come to one of these bodies and right click on it and hit hide body, and then you can come in here and you can zoom in, and when you click on the force you can click this top line if you're in the line select tool, and if you click on that top line it'll apply the force along that top line, and that's what I've done here. You can see it's along one edge. I switched to force components and I entered in a minus 5,000 pounds force. You need to make note that this is all in English units now as compared to what we were doing in space claim. So if I was wanting to really make sure my answers were right, I need to come up here and change my units to metric units. And then I could put in this load correctly as 5,000 newtons. And I can do that. I can just simply come to the Home tab, click on Units, and change this to metric millimeters. And you see you have a lot of options here. The one that is typically used is this metric millimeters, kilograms, newtons, so and so forth. So if I change to that, you can now see that my force changed to minus 22,000 newtons, which is quite a bit bigger than the intended load. So I could change this to minus 5,000 and click enter. Now I've got my force applied, so I can move on to analysis settings. And what you want to do in analysis settings, whenever you have a joint connection, you're going to want to come down here, and on large deflection you're going to want to make sure that's turned on. So you can hit the drop down and and turn it on if it's off. By default, it's usually off, but anytime you use a joint connection, you want to have large deflection on. Now, in terms of solution, the outputs that I'd want, I can come here and double click on solution, click solution up here. I'll probably look at a total deformation, and you can see all the things that I've already listed here. I did an equivalent stress, maximum principal, normal, shear, total deformation. And here's my joint probe. So coming over here to probe, what you want to do is click on probe, come down to joint and click joint probe. That will bring up this. And then on your joint probe, you need to make sure that your boundary condition that you pick is your general to ground. That should be the only one you have in this model. And then you'll want to make sure that you change the result type from the default of total force, and you'll want to hit this scroll down and come down and click on relative rotation, because we're trying to figure out how much this non-symmetric cross section is going to rotate and open up. And then on my force reaction, what I've done here is I've just gone up to insert this force reaction so that I can make sure that the total load is carried by my reactions. And this is just kind of a sanity check to make sure that you are getting the same reaction forces as the loads that you have applied. So I can go ahead now and hit the solve command on this. And as it solves it, it should solve pretty quickly. And what it'll come up with is a table over here that will show me the rotation on my structure, and it'll also give me all the stress values. You can see that so far no messages. I'm progressing good. It's all green arrows here now, and I can come up to show all bodies. Now I've got everything in there. I can look at the equivalent stress, and I want to make sure that that looks right. I know that my stresses should be maximum in the middle of the beam, and it appears like they are indeed maximum there. I can look at my directional deformation, and this is X direction. Should have set that for Y, so I can come here, click the drop down and click Y, and I can hit solve on this, and this will be really quick because it already has the data. So now I'm looking at the Y axis. I can look along, click on the Z over here and do an ISO view, or look at the X, and if I click on directional deformation, I can see that 0 on these edges like I should be, and I get bigger and bigger as I come to the middle. If I rotate this around, I can see that my largest deflections are right here on this, and then here on this part of the beam. If I come to the joint probe, this is where I can see the angles of twist and so forth. So down here you can see that the rotation about the x-axis is extremely small, e to the -4. Rotation about y is very small, e to the -7. And then when I look at the rotation about the z-axis, I am 0.92 degrees. So I've rotated some about the z-axis. Another way to look at that, it's sometimes helpful, is to look at it on the end and zoom in and control middle mouse button, move it, and you can see that there's a little bit of deformation of the cross section and a little bit of rotation as we look in along the z-axis there. Here you can see it's not quite square, and this is rotated out, and here in the middle this is rotated down some, and here it's rotated down some. So I could increase those and look at those dimensions if that was more important. I come to force reactions, and I can see that my force reaction in Y is 5,000 newtons. That's what the force that I applied, so it makes me feel good that my reactions are working and my model's in good shape. So this will conclude this tutorial on non-symmetric cross sections and bending of those non-symmetric cross sections, and looking at the angle of twist and how the cross section opens up. Hope you found it helpful. Thanks for watching.